In section 3.5, we want to expand on our repertoire of basic derivatives that we know. And we're going to expand into the trigonometric realm. So we want to be able to find the derivatives of sine and cosine just for starters. And then we'll learn some other rules as well. I'm not going to prove these per se, we're just going to kind of talk at them a little bit. So the derivative of sine is cosine, and the derivative of cosine is negative sine. And I have the graph here, but I can also show it to you on Desmos. So let me pull that up real quick. All right, so I have the graph of sine of x graphed right here. So this is sine of x like this, right? Which is actually the black curve that you see on your sheet of paper. So that black curve, that is sine of x. And you can see that f prime of x is this curve right here. But according to me, that should be equal to, let's see if I can get this to work, this g of x, which is cosine. Did you catch it? So f of x, f prime of x is g of x. They are one and the same, right? So the derivative of sine is f prime, which is cosine, right there. So that's the first thing to notice. Now you'll also notice something else. When this graph has a maximum, when the sine graph has a maximum, that means that the derivative graph has a zero. So at pi over 2, for example, the sine has a maximum, so the derivative, the cosine graph, has a zero. So let me go back to right here. And that I matched the colors right there to what we have here. So we have kind of this reddish pink graph. This is cosine of x right here, right? I'll call it g of x, for example. And then the black curve right there is sine of x. This is sine of x, which is f of x. All right, so the derivative of sine is cosine, because where this graph has a maximum, the derivative has a zero. And that would give you a horizontal tangent line right here. So if you have a horizontal tangent line at that maximum, horizontal tangent line, then the cosine graph would have a zero or an x-intercept right there. And this horizontal tangent will happen a max or a min. It'll happen over here at this maximum, or it'll happen over here at this minimum. Right there, there's a horizontal tangent line, so the derivative is zero right there. So that sort of semi-proves the derivative of sine is cosine. Let me bring back Desmos real quick. So let me leave cosine up. Cosine is this red graph. And according to my rule, the derivative of that should be equal to, let me change my color here. I'll go green. There we go. All right, so that should be equal to sine, and it is, or negative sine, excuse me. So see, maybe those colors aren't different enough. So purple is g of, or g prime of x, and then I'll make orange h prime of x. See it? Purple, orange, g prime, negative sine. It works, right? These two functions are the same. I realize that's not really a proof, but you know, bear with me. So it works, and you can read about the proofs in the textbook if you're so interested. All right, so that means that we can use those two new rules now, and those are two rules that we definitely want to memorize. This is rule number 13, and this is rule number 14 in our table. So if you look at rule number 13, rule number 13 says derivative of sine is cosine. Again, we're ignoring the u primes for right now, but we'll deal with those later. And the derivative of cosine is negative sine. And then we're currently dealing with just x, so u prime is just 1 for us right now. Okay, so let's use those to find some derivatives, shall we? Okay, so we'll take them out for a spin. Well, I have these kind of out of order. The easiest one is actually letter B. So I'm going to do letter B first because it's so simple. So letter B, the derivative of that is dy over dx, which is the derivative of cosine is negative sine of x minus the derivative of sine is cosine of x. And you're done. That's all there is to it. Of course, these are going to get combined with other functions, and that's what's going to make them more interesting and fun. And by that, I mean difficult. So let's look at this one. Here we have two functions. I can call them f and g, or I could call them u and v. It doesn't matter. I think I'll call them u and v this time, just for something different. So if I call that function u, that function v, then dy over dx would be equal to, I'm going to need the product rule here, right? So we're going to need product, which is rule number 7. Rule number 7, we're going to need product. I'll just write product up here. Okay, so that means I'm going to have to take the derivative of the u. So I'm going to need u prime. Oh, rats. We didn't know how to do this yet, so pretend there's no 5 there yet. Sorry, that was from an earlier, I will fix that for future. That's a typo. That was from an earlier version of these notes. So let's make it e to the x. So u prime would be e to the x, because e to the x is its own derivative, times, and then v, leave v alone, so sine of x. So we take the derivative and then leave the v. So this is u prime, this is v, plus, and now we leave the u alone, so e to the x, and then take the derivative of sine, which is cosine. And there we have it. So it's e to the x sine of x. Let me just make sure this is clear. This is u prime. This is v. This is v prime over here, and this is u. Right, that's what we're doing here. Let me make that clearer. U prime v plus u v prime. That's what we're doing. Okay, so that's fine. I mean, this is perfectly good as an answer if you want to write it right there, right? Or we could factor e to the x out, and that would leave me sine of x plus cosine of x. That's also acceptable. Either one of those is totally fine. Okay, now what about this over here for letter C? Well, let me just rewrite that. That's really sine of x divided by cosine of x. Right? This division bar right here is right there. So I'm going to need quotient rule. I'm going to need to use rule number 8, which is quotient. Okay, so the way quotient rule works is if I say that this is u and this is v, I'm going to take the derivative by taking the v, so dy over dx equals, oh, I should have written that a little bit higher. 1 second. Okay, so I need v squared in the denominator, so cosine of x squared. So cosine of x goes here and gets squared. Cosine of x goes right here. So you write your v, your denominator here and here. Then I need the derivative of the numerator. Well, the derivative of the numerator is the derivative of sine, which is cosine. So that's u prime right there. That's what I'm doing. Minus, and now I need v prime, derivative of cosine's negative sine, times u, which is sine. Okay, well, let's do a little bit of simplification. Technically, we're done right here if we want to be, but I want to simplify this for my own benefit. So to simplify it, that would be cosine squared of x minus a minus, so that's plus, sine squared x over cosine squared of x. But this should be setting off little bells in your head. That's a trigonometric identity. Sine squared plus cosine squared is equal to 1. That's the Pythagorean identity, the base Pythagorean identity. And then this is another little alarm bell because 1 over cosine is by definition the secant. So this is the secant squared of x. And you've actually just proven the formula that's on the next page for the derivative of tangent, because sine over cosine is equal to the tangent, and so the derivative of tangent is secant squared, which is right here. Derivative of tangent is secant squared. Just real quickly before we go to that other page, I just want to mention that I use the Pythagorean identity to go from here and the secant identity to get from here to here. And you could do the same kind of argument to come up with the other derivative of trig functions. So we have the derivative of sine is cosine, derivative of cosine is negative sine. We just proved the derivative of tangent is secant squared. It's almost the exact same argument for the derivative of cotangent is negative cosecant squared. Derivative of secant is secant times tangent, and derivative of cosecant is negative cosecant cotangent. All of these have to be memorized for your pop quizzes in class. They are the last of the ones that you have to memorize, though. There are a few that we haven't covered yet, and you'll have to memorize those, but you have to memorize 1 through 18, and there at 18 is the derivative of cosecant. The 6 at the bottom you do not have to memorize, but you will have to use them. We've skipped over a few in here, namely 10, 11, 12, and number 6, and we'll get to those in a later section. And also what all the U's mean.